So let's have a look at question 24 from the 2013 revised higher physics paper. This is a question relating to special relativity, and it says that there's a website and it has some information about relativity. The website talks about the Lorentz factor, which appears in relationships for relativity to calculate length contraction and time dilation. The Lorentz factor can be represented by the symbol gamma and is defined as such. Now we commonly use this to determine either the dilated time, which is the normal proper time multiplied by the gamma factor, or the contracted length, which is the normal rest length divided by the gamma factor. And what you'll notice from the graph just there is that as the speed of the object that's moving gets closer to the speed of light, i.e. As the value goes toward 1, then this gamma factor starts to increase exponentially and becomes very, very large at speeds where this velocity is very close to the speed of light. Around here, which is about 0.1 of the speed of light, then effectively you're not really seeing any increase in this Lorentz factor. It pretty much stays at 1, and so therefore if that value is 1, we multiply it by our time. The dilated time doesn't really change, and so the same is true for the contracted length. But as you get closer to the speed of light, this value of the Lorentz factor increases significantly, and so that means that this value is now much greater than 1, and multiply it by our time, we get a much larger time. The dilated time is big. Or if we divide the rest length by the gamma factor, if this starts to become big, as it does here, then the contracted length is going to become much smaller. So anyway, on to the question. We'll just clear that stuff that we've got on, and we'll have a look at the question. So the question is, what is meant by the term length contraction? So we're just going to clear some space here. Let's see if this works. Just to wipe out all that stuff, and we want to just answer the question here, what is meant by length contraction. Well, as we said a moment ago, as things approach the speed of light, time is dilated, which means it slows down, and length is contracted. And of course length is contracted by the amount L dash is equal to L, the rest length, over this gamma factor. But there's a couple of things that are important about this contraction of length. The first thing is that it's only noticed by an observer who is relative to the moving object. So if we have an object here that's traveling at a certain speed, v, where v is very close to the speed of light, and thus the gamma factor is large, then a person in this object, say this is a vehicle, wouldn't really notice any change. There's no physical manifestation of a change in length of the vehicle that they are in. But an observer over here might look at that object and see that actually that object appears much shorter to them in the direction that it's traveling. So it shrinks in this plane. It doesn't shrink up and down, it shrinks in that plane along there. So it's contracted in the direction that it's traveling, and it's only observed by an observer who is relative to the moving object, not one who is in the moving object. So then if we want to put some words to this, we'll just add the text and say the contracted length is the change or decrease in length, and importantly in the direction of motion, as it says in the solutions, of the moving object relative to the observer. Okay, so I hope that's clear. If you didn't quite get it, go back, have another look at the video, and hopefully it'll become plain to you.